Welcome to the Long Range Pursuit Podcast, presented by Gunworks, where we learn about and share long-range shooting techniques, science, and gear.
All right, we're back in the podcast studio. We're calling this one today The Science of Suppression. I was going to maybe call it like The Sound of Silence, but I think that one's been taken. Mm-hmm. We've done quite a few suppressor-focused podcasts over the years. I think most of those have been a little bit more about, here's a new cool suppressor we've done. Here's why you should buy a suppressor because we love them. What I wanted to do today is dive a little bit more into the technical side. Mm-hmm. This is kind of for the geeks, the guys that love to just kind of learn a little bit more about the backstory and the inner workings and what makes a suppressor and maybe some of the things that we've learned over the years about suppressors. The marketing guys have been kind of pushing us to get some product focused podcast episodes out for the last few months. And so this is kind of the thread or a theme of these a little bit more technical topics that we're exploring lately.
Yeah, definitely. I think really our aim is to kind of educate our customers on, we're not just doing suppressors and, we're not just turning them on the lathe and welding them. I mean, there's a lot of science behind it, a lot of engineering and factual based decisions that we make along the way, for the metrics of the product. So just help educate our customer on what we look at and what's important. And that's really where we try to focus is look at the fundamental things that matter in the design of any component and really double down on that and let that kind of drive, the design, the process and eventually the end product.
Right. And like anything we touch, we're always trying to improve it and make it better. I think must have been 2019. Don't quote me on that we launched that first line of suppressors. We had our 6 and our 8 steel suppressors that we launched. So it's been, 5-6 years since we launched that first line of suppressors. Yeah. And so I guess probably what's kind of top of mind for you and me is we've been doing some pretty serious suppressor work here over the last couple of months.
Yeah, we don't want to tip our hand too much here, but we've got a new suppressor in the works right now. Yeah. Really diving in on a lot of different, seeing if we can get any gains, getting away from the M baffle design that we have now. Yeah. Also looking at some 3D printed processes and things of that nature, but really letting sound kind of drive that whole sound and precision drive that whole project. Right. So,
and I guess before anybody gets too antsy, keep in mind we've always got a bunch of products in the works. So it doesn't just because we say we're working on a suppressor now doesn't mean that's coming next month or next year or whatever else. Right. Yep. We're working. And I think especially as I think we've talked a little bit recently, as we've kind of matured our product management and our engineering processes and teams and timelines, we're able to get a little farther ahead all the time on some of these projects. And so we're working on timelines and project and product lines that are 3, 4, 5 years out right now. So, it'll be here when it'll be here, but don't be necessarily knocking down the door next month.
That's the big one. We're not in the game to just make a suppressor for somebody to buy,
kick it out the door and make a quick sale.
Yeah. We just, a few weeks ago finished up our version 1 of this suppressor, right? And we learned a lot about where we were and we didn't quite hit the mark. So we're not ready to go. Right. And we're not going to release it until we've hit some of those goals on the project.
Right.
So,
right.
Yeah.
I'm kind of a geek when it comes to some history and just some background. You've got the notes in front of you, so you get the cheat sheet. But would you have guessed when the first suppressor was invented?
So let's just back up for prior to when Josh was at Gunworks and privy to this info. I would have said maybe 2000. For the first suppressor, because it really wasn't commercially available.
Sure.
Or popular until the early 2000s. Right. A few of those companies coming on the scene, but I was really shocked to find out like early 1900s.
Invented in 1902 and patented in 1909.
I know.
Hiram Percy Maxim. This is old tech, right? One of the coolest things I think is Theodore Roosevelt hunted with suppressors. Like if you go down to the Cody Firearms Museum here in Cody, there are rifles in the museum that Teddy Roosevelt owned with suppressors on them. Yeah. So this is not a new thing on the block. Now it's become way more visible and popular over the recent years, right? It was very, very niche prior to, I'd say, the 2000s for sure.
I think a lot of it, like, Percy he was ahead of his time, really what it is. And I think how it's become commercially available is manufacturing processes.
For sure.
You look at, most of those designs you couldn't CNC machine him. He didn't have a CNC machine. Yeah. So, he was stuck with probably doing some sheet metal processes and trying to bend metal in the right directions and really basic machining.
Right.
Which that's just, in some instances, it is economical. In a suppressor, it's not.
Yeah.
And, you got 3D printing hitting the market now, and that kind of, unleashes all design restraints you have on CNC machining, right? So I think we'll see it keep progressing. But I think that's really what's driven it is CNC processes, being able to be scalable and also economic at the same time.
Yeah, definitely on the manufacturing side. And then I think you've got the consumer side where consumers are realizing how awesome they are, how much of a improved shooting experience it provides, and all the benefits. Not the movie silencer kind of thing that you see watching the movies, but the actual real world in the field applications for not spooking game and not having to track game as far and saving your ears for future. There's just I think probably the current generation of shooters has done enough damage to their hearing that they're learning. If only I'd have had a suppressor, right? So it's like I'm shooting suppressors with my kids because I want my kids not losing their hearing.
Exactly.
Like most of us have already.
Yeah, exactly. And I think another thing that plays into that is kind of the NFA, right?
Yeah.
I think there's a lot more I think it was intimidating for a lot of people for a really long time. And you have some companies kind of breaking down those barriers and understanding the process and kind of dumbing it down for the consumer to a more palatable version of what it takes to get a suppressor. So, the NFA, basically, they restricted them in 1934.
Yeah.
And we've kind of had, 90 years up until now.
Right.
And a lot has been understood there. And wait times right now are 2 days,
So, recent news, right? This is just in the last maybe 2 months is the ATF has changed how they're, I would say, triaging Form 4s as they come through and get approved, their process.
Yep.
And so, I've kind of learned, I think a lot of us have learned not to trust anything until we see it there. They were saying they were down reduced, that it was going to stay that way. So far, for the last couple months, it's stayed very, very quick. Guys are getting them back in a matter of hours. A lot of guys in a couple days.
Yeah.
I would dare say if that change, if it stays that way, that, and this is maybe a bold statement, but I think this is the biggest change to anything suppressor related that's happened in the space since the NFA was created in, what was it, 1934? Because if you think about it, ever since then, I can't remember what the number was, but that tax stamp, the number hasn't changed since the NFA, right? So that was like a $2,000 or $3,000 or $5,000 tax stamp, approximate if you adjusted for inflation over that time back then, right? That was a lot of money back then. Okay, so it's a little cheaper nowadays because inflation, that number hasn't changed. But with that time change, that processing time change on tax stamps, to be able to get a suppressor in a matter of days instead of a year is absolutely a game changer. There's, there never really was a reason guys shouldn't be owning suppressors, but now without having to wait for a year for one, there is almost no barrier there, right?
Yeah.
Go get your paperwork done in an hour down at the local SOT suppressor dealer, and a couple days later you got your suppressor and you're done.
Yeah.
Awesome.
Yeah.
Awesome.
Yeah. I think it's going to be good for everyone.
Yeah.
Us included. My first suppressor, I had to wait a full 365 days, to the day. I had to wait for it, and it's painful waiting all that time, especially when you're excited about it and it's a big expense for a lot of people.
And I think guys sit back and think, man, I'd have to wait for a year, and it's not logical, but it's just one more excuse to not go do it, right? But I think with that, it's almost an impulse buy, that instant gratification to be able to get one that quick. I think that really changes things for sure.
Definitely.
Pretty exciting.
Okay, well, let's. I think maybe now let's dive into kind of more of the details on a suppressor. As I was kind of preparing for this, I really I like to put things in simple terms, right? I mean, we're basically, we have a powder in the chamber, and we're burning that powder and turning it into a gas. And suppressors are all about managing that gas. And it's just a function of volume. And that the two biggest effects you can have on that is your diameter and the length of the suppressor.
Yeah.
There's a lot of stuff that I don't think is understood in great detail on the optimum volume, but there's certainly a optimum volume per caliber, which is very hard to do because it gets so niche so fast, right? So really our bread and butter will continue to be optimizing suppressors for the big Magnum calibers.
Right.
A lot of our competitors are looking at, the 5.56 fully auto rated type suppressors.
Right.
And, that's just, we can learn a lot from that, but that's not what we do here. And, that's kind of where we'll continue. So, I mean, when you get into the guts of a suppressor, I mean, we talked about length and volume, but really it's just managing those gases is what's going on. And, it's a very nonlinear thing, which is when you measure it, and it's very hard to predict nonlinear equations. And it's also, the gas is turbulent as well. So you got laminar flow that's nice and smooth, that's the nice slow moving part of the river. And you got turbulent flow that's like your whitewater rapids. And that's also really difficult. So that kind of drives designers to a more iterative type of approach in design. Right? I mean, you touch on fundamentals, like we know we can learn from our current 6+ and 8 what volumes do good and how many baffles to use. So we can kind of lean on that and, learn from that and improve from it. But, overall, it's like you don't learn much about suppressors until you've tried them, especially when you're getting away from those traditional designs of M baffles and K&M baffles and things like that.
Now, to take a step back, the way I've always understood it, and always nice to have an engineer here that can correct my layman's terms, but I've always understood essentially, there's two sources of sound you're getting from a rifle, maybe a couple extra, but the primary would be the muzzle blast, right, which is essentially a sound wave created by those gases exiting the muzzle really fast, right? So that's creating a sound wave. And then the second would be the supersonic crack of the bullet. If it's a supersonic bullet, most of what we're shooting are. And so two major sources of sound. Now you've got the action cycling and some other things happening, maybe mostly on semi-autos and full autos. But I think those are the two primary sources of sound. And really, if you've got a bullet moving supersonic, there's really nothing you can do about the supersonic crack, right? It's like a supersonic jet going by. It's always going to make that sonic boom.
You're mainly insulating that crack with the suppressor, and then the rest is that gas.
Is the muzzle blast, that we can really control with
That's
the
exactly
suppressor,
right. Yep.
Right. So we're trying to contain those gases exiting the muzzle and slow them down to the point where if you can slow down the movement of those gases, you can reduce, or what would you call it, change or attenuate that sound wave that's coming from the muzzle.
That is your bullet's going supersonic and the gases are also going supersonic.
Right.
The whole goal of a suppressor is to kind of get those gases subsonic before they exit the end of the suppressor. So I thought it'd be kind of good to talk numbers too. So, generally it's going to depend on lots of different factors, but generally a unsuppressed rifle shot is 160 to 170 decibels. I mean, we all have put a muzzle brake on a barrel and experienced a louder shock. And that's just that sound basically leaving the sides of the muzzle instead of going away from you. That gets up to that 170 to 180 decibels. And a lot of the suppressors on the market, the real goal is to get it under 140 decibels. And that is, it's proven by MSHA, OSHA, NIOSH, all those regulatory agencies that 140 decibels is where permanent hearing damage happens instantly.
Beyond that.
Yeah, exactly. So, that is kind of the line that all suppressors that should be going for that 140 decibels. Obviously quieter is the better, right? So, we're trying to beat that. And then when you get into some of our longer, bigger suppressors, we're trying to get down to that 130 decibel level. So, and it's, like I said, it's all a function of kind of what the baffle design and how it's disrupting that gas flow and slowing it down. And also just what that, initial volume is doing in the suppressor itself to mitigate that crack.
Maybe that's a good time to explore the decibel rating system. I think this is something that everybody in the firearm and suppressor industry, owning suppressors, whatever, you're shopping for one, you see these numbers. Frankly, I think to most guys, they don't mean anything. It's just it's a number. And on top of that, it's not even a linear scale.
Yep.
Right. And so I think trying to break that down and help people understand how that works, I think is valuable.
Definitely. Yeah. That's, you kind of got to take some of these decibel values with a grain of salt, because it's so dependent on, the test setup and the environment you're doing it in. Like the PhD level guys, they'll actually run these tests in an anechoic chamber, which is basically a cube, a room that's shaped like a cube filled with foam for the most part. And the sound event happens at the geometric center of that cube. And the reason for that is they're eliminating as many variables as possible.
Echo and
everything else. One of the biggest things that's hard to predict with sound measurement is you have the sound event, and then you have sound waves reflecting and coming back. So basically, I mean, those are both things that you experience as a shooter, but when we're trying to measure those, trying to discern what was the sound event and what was that reflection and how to process that data is a really big deal.
Right.
So that's kind of where, I wanted to touch on the ASA, the American Suppressor Association.
Yeah.
They're kind of taking some initiative here on standardizing all of that. So when customers see a decibel value, you'll probably see this ASA logo with it that basically denotes that this was run with a standardized test setup.
Yeah.
So they're really looking to standardize, if you're doing it indoors, you're going to set it up like this. If you're doing it outdoors, you're going to set it up like this. I mean, it all depends on, you have this rifle going off, and are you shooting it over concrete or are you shooting it over grass?
Yeah. Two
very different things. So when you're measuring sound, I mean, there are a lot of variables, and the more you can control, the better.
If anybody has bought a Gunworks suppressor or shopped Gunworks suppressors in the last few years, we did not publish decibel ratings, and we had a lot of guys come and asking, what's your decibel rating on this suppressor? And our answer for guys was, it's complicated, but our feeling was that most of the decibel ratings that people are reading associated with suppressors are not reliable or accurate. And that's not to say that somebody's lying to you, but it's to say that it's not always an apples to apples comparison because it is such a complex thing to measure.
Yeah.
And it takes very, very specialized equipment to measure accurately, and very, very specific and specialized setups and conditions to do so. And what we learned early on in our original suppressor development projects was that we simply were not confident in a number. We knew that our suppressors were good because we had tested them side by side in identical conditions with competitors' suppressors. And we knew that it was quieter than this one and quieter than that one and as quiet as this one. But that specific number just was not relevant or actually comparable to anything.
Yep, exactly.
Now, I think where we're going here is, like you mentioned, with the ASA developing the standard and hopefully getting a lot of industry members involved, we can standardize enough to where people are confident in a number. And, it comes down to the humidity in the air when you're testing it. It comes down to, is the microphone positioned in this place or this place? And are you using the right microphone? Because most guys that are doing decibel ratings are not actually using equipment that's rated for it, right?
Exactly.
So anyways, it's a really messy thing, and we're working towards finding that place where we can be confident in a number, and hopefully the entire industry can work that direction. But just that's a little bit of background.
So, I mean, we got all the variables on sound measurement, right? Then we talked about how it's a non-linear thing. Yeah. That's why. So sound,
it's a logarithmic scale, right?
And basically where logarithms are used is when you have a very exponential curve, it's hard to predict where that data is going. So what it does is kind of mines that data out into finite elements to where you can kind of evaluate what's going on. So you've got that going on because it's a very fast event. So you start looking at your sample rate, right? Like we have part of this ASA thing is you have to have 100,000 samples per second as a sampling rate. So you think about, okay, now I've got 100,000 data points. I mean, that's their minimum. They want more.
Sure.
I mean, so you start looking at that. Now I've got all these data points to go through. And then on top of all of that, you've also got different scales. So sound is weighted for different applications, where, you know, the A scale is what's most common because that's weighted for the human ear.
Okay.
And what that's doing is you've got different frequencies of sound, and it's weighting that specific frequency to the human ear. And basically what that boils down to is one frequency will have a lot of intensity, whereas a lower frequency will be less intense. So it's kind of weighting that out.
Sure.
So that's where you'll see that on published data, the dBA.
Yeah.
That's what I always look for, to know that it's in the A scale.
Gotcha. Okay.
So, I mean, you have all that kind of piles on top of each other. It's, I mean, having a standardized system so that we don't have all these different competitors advertising different things, I think will be good. And I do hope that the industry starts to adopt that. And it's definitely the path that we're on right now.
You know, the thing that I found interesting, I mean, you know, guys are familiar with that logarithmic scale, but essentially what is it? It's 3.4?
3.3. Yeah.
3.3. So essentially 1 dB difference. You know, you go from 148 to 147. That's 3.4 times.
Yep. Yeah. Well, so yeah, how it kind of shakes out is at 3. I mean, the metrics that I kind of have in front of me here is 3.3 decibels is double or half, depending on which way you go. So, I mean, 2 dB, 3 dB doesn't seem like that much, but with it being on that logarithmic scale, it makes a huge difference into the overall, the value. So, definitely something that we like to pay attention to. And, you know, that would be my thing for the customers is those small, what appears to be small is actually a really big difference on the overall rating of the suppressor.
For sure.
Yeah.
Okay. Well, we talked a little bit about how a suppressor works. Maybe we dive in a little bit into some of the construction types next. There's, you know, it's over 100 years of history there. Technology has changed dramatically over those years. And I think, you know, guys are pretty inventive and creative on finding different ways to create a suppressor. I think there's kind of a couple core methodologies and, you know, probably several exceptions to that as well in the industry. But yeah, maybe dive in a little bit on some of the different
we could kind of explain that. I think the most common baffle construction in the industry is the M baffle. So that's where you see it's just a straight cone, and it's a bunch of cones stacked on top of each other.
Right.
I think the next most common is you have a K&M baffle, which is a little bit, it's still connular, but you still have basically gas ports that bleed out the end of the cone and then dump it into a volume.
Into a secondary.
On the outside of that.
Right.
I'd say those are the two most common, and I mean, they're not common by chance. I mean, they work.
Right.
So, and that's why we kind of chose that. The M baffle is very easy to produce, and you can weld them together with great success, and that's kind of why we opted to do that the first time. Then, I mean, outside of those two baffle types, those are going to be your kind of stacked baffles, I'll call them. Outside of that, another one that's fairly common, a little bit older, is your monocore type of technology. That's basically a tube that's got a machined either steel or aluminum insert in it that helps to manage that gas.
Right.
And then I think they're not as common, they're becoming more common, but a coaxial type of design where you kind of have an inner tube and an outer tube, and you're kind of routing those gases from inside to out.
Right.
Similar to that K&M baffle style.
And the approach is really just directing gases and trying to move gases in ways that you can slow things down and let the bullet pass through.
Exactly.
At the same time,
The overall theory is you've got a bunch of gas trying to enter this suppressor, and you know, if you look at our 6+ and our 8, we have an expansion chamber at the very beginning. That kind of takes the biggest shock, so that's going to be the strongest component of our suppressors, and it takes that initial volume out. And then you get into our blast baffle, which is a little bit bigger than or smaller than our expansion chamber, but still bigger than our baffles. It takes a little bit of gas out of the equation. And then you get into all of our baffles, and each time you walk down the suppressor, you're taking a little bit of gas out with each respective baffle.
Right.
And basically as it's moving down, there's less and less gas trying to flow through that suppressor, and your gases are slowing down because there's less volume pushing on that, going through it.
Right.
Another baffle style I wanted to touch on a little bit is a asymmetric style as well, which it's basically got a bunch of different, it's similar to the monocore I was talking about, where it's just got a bunch of baffles that are oriented at random orientations. There might be some M baffles mixed in there. But the baffles are more or less angled in one direction to force the gas up, down, left, right. And then, you force that gas into a chamber or a tube or route it in some manner that is going to help slow that gas down.
Right.
But like I said, the M baffle or the K&M baffle, they're very effective in what they do. And that's why you see it all over the industry.
Yeah. And I think there's a kind of a balance there that we're learning, diving into some of these recent projects is, you've got the desired geometry that you're working towards, and then you have a construction method, right? Or a manufacturing method.
Yep.
And you have to learn to marry those two.
You do.
You may find some limitations, right? That M baffle design, that, connular baffle that we designed in our original suppressors is really efficient, and it lends itself really well to a welded suppressor, right? So there's no outer sleeve on that suppressor. The baffles themselves are the outer surface of that suppressor, and you're just welding those baffles together. It's really tough, or we haven't really found a good way to make a coaxial suppressor with that method. Right. And
there are
you need
ways
to start,
they just get
there's
heavy.
ways, but exactly. And so you start learning, okay, well, if we need to go this direction, that's going to steer us to use this method or these materials, and vice versa. Definitely a lot of moving parts to play with there.
Yeah, definitely. I guess we should have started with this, but let's talk about what a suppressor does. I mean, we didn't really touch on that the first one's obvious, we're looking for that 140 decibels or less. And we've already talked about, how we manage gases. But let's kind of talk about, I think the other two effects that it has on the shot experience is precision and then also felt recoil.
Right. One of the biggest questions we get is it going to improve my accuracy or hurt it? Right. I mean, I like how my rifle shoots. What's the effect going to be? Right. And I think what we find is, and you probably have some data to back this up, but usually my response is, if anything changes, it's going to improve your accuracy. I've very rarely seen a suppressor reduce accuracy. And I think, now you can validate this or not, my theory is that you're essentially adding a large mass on the end of your barrel, and there's inertia. Essentially, that mass wants to stay in place, right? And so, like a stabilizer on the end of your bow kind of thing, it wants to stay in place. And so you're reducing movement in that system when you add that mass on the end of your barrel.
I think at the end of the day, you are adding a very large mass, and the overall input into your rifle system or in your barrel in particular is the same. But adding the mass out there changes the harmonics of the barrel.
Right.
And I think barrel harmonics are very largely misunderstood. Or I guess they're not understood very well.
It's complex, right?
It's very complex. I mean, when you get into vibration, I would say it's equally as complex as sound measurement, because you can't see it, you can't feel it. Like and it happens in a very short time frame, right? So it's almost as complex there. But I mean, at the end of the day, your barrel is going to flex. I mean, generally up and down is the mode based on inputs from the action when it goes off. And adding that weight out there is going to just change how much your muzzle is moving overall. So at the end of the day, like barrel harmonics are just a function of how fast is your muzzle moving and how far is it moving.
Sure.
And I think a lot of the inaccuracy from barrel vibration is just that bullet's leaving the barrel at a slightly different point in its deflection.
Right.
And I think suppressors definitely help tune that down. Your velocity is less and the overall deflection of your barrel is less. There go. Your precision is going to be a little bit better.
And there are probably some other, maybe I'd call it soft impacts there, such as less flinch in the shooter.
Yeah.
Right. Some other things like that, making the rifle more shootable, which is going to obviously have a significant impact on how you actually shoot the rifle.
Oh yeah. I definitely, that's kind of, to be honest, that's one of my top things with a suppressor is my confidence in the shot is just a lot higher because I'm not anticipating that shock and that, that recoil.
You mean, people talk about recoil. I think there's almost more effect on the shooter from muzzle blast than there is on recoil in a lot of cases. Yep. And I think back to growing up, we didn't shoot with suppressors. A lot of times we didn't shoot with brakes, but man, I'm telling you, some of these, having shot some of these big brakes on these rifles, you're doubling up on ear pro just to keep from having your ears ringing at the end of a range session. And I think that muzzle blast is not given enough credit on its impact on shooter experience compared to the recoil aspect of that.
Yeah, you're absolutely right. When you get into some of those really aggressive breaks, you look there, those ports are they're pointed backwards and kind of pointed towards the shooter. So that's where all that gas is going to go in that shockwave.
Right.
And what the trade-off there is the gas is leaving the muzzle. It's hitting those baffles and heading backwards. So it's pushing the gun forward while it's trying to come backward.
Yeah.
And that's a similar effect that a suppressor has. You've got all these gases going into the suppressor, hitting all these baffles, pushing it forward. It's just those baffles aren't angled backwards at such an angle. So generally your recoil isn't as good as a well-designed muzzle brake, but you're still getting less recoil than a
unbraked rifle, basically.
Yeah, exactly. Yeah. So, and then one other effect that I wanted to touch on here, and I know we've done it in past podcasts, but is point of impact shift.
Yeah.
There is, it's something that I don't think anybody understands very well, us included, but I've done a lot of testing on this, and I haven't been able to draw a conclusion on we have a 6+, it's going to move your point of impact this direction and this far.
Yeah.
It's been so random. Like I've had builds where, my personal suppressor on my 6.5 PRC moves a half a minute when I put a suppressor on compared to a brake.
Yeah.
But I've had ones that I've seen suppressors move like 6 minutes.
Yeah.
Like
I would say I've seen average
3
to 4 minutes probably. Typically varies. I feel like I've seen it move more with bigger and heavier cans. This is my theory. I want you to go prove it or disprove it, is that it's barrel droop. It's that simple. And every barrel is going to have different stresses in it, right? It's like, a minute pressure from one direction or the other is going to create slightly different deflections, right? And so you hang a pound or a half pound of metal off the end of your barrel, and you're going to have a very small amount of deflection from that, but that equates to approximately a couple minutes of.
But I've seen a lot go up. So let's talk about that.
Very few, but I have seen some.
They do go up, and I'm going to go back to barrel vibration.
Yeah,
and how it, like I talked about, that muzzle's moving and it's moving around. That suppressor just changes that input into that.
You'd have to go shoot 100 barrels with 100 suppressors and plot it and see if there was any trend there.
Yeah,
I sure feel like the majority I've seen move down.
Yeah,
but that'd be interesting.
Definitely
TBD. I guess we need to go do a little science experiment.
There's more we got to learn there for sure.
Yeah.
And we're getting a lot more tests set up. More equipment to help measure that stuff and drive informed decisions
right
into the future. So. I guess, so we've talked about effects. Maybe we should talk about, we talked about common designs. Maybe we should talk about materials.
Yeah.
That are the most common.
Sure.
The two that seem to lend itself the best is stainless steel,
right,
and then also titanium.
Yeah.
Right. And there's a few trade-offs there. With the stainless steel, you're getting very good material properties. It's cheaper than the titanium, but when you start looking at kind of strength to weight ratio, titanium wins all day long.
Yeah.
So I mean that's the reason we came out with titanium suppressors.
Right. Well, it's driven the entire. If you look at the history of Gunworks suppressors, we started with steel. They were cheaper. They were easier to machine, easier to engineer and work with. So it was the logical place to start.
Yeah.
And then a couple years down the road, we launched essentially the same line of suppressors in titanium. It's 40% lighter, so guys are saving a lot of weight there, and essentially the same performance out of that with that same weight or that 40% lighter package.
Yeah, definitely. It does come with a trade-off though, right? And
we've learned that.
We've learned that, and also, I mean, it's the biggest one that I see is the thermal aspect of it, right? I was just kind of putting some numbers to it. The thermal aspect of heat transfer is thermal conductivity. And that's just the material's ability to transfer heat, how fast it does. And, when you compare the stainless to the titanium is about 3x. So it transfers heat 3 times faster.
Right. So it heats up faster, but it also cools faster.
Yeah. So it'll cool at the same rate. That's the one thing that I see, especially with barrels. People talk about how it's slow to heat up and it sheds heat faster. Like that's a two-way street. Like it heats up as fast as it cools down.
Sure.
So that's just something to keep in mind. And the biggest thing you're going to see as a customer is the Mirage. Off of that, I find with a titanium suppressor, I mean, you get 5, 6, 7 rounds through a can, like that Mirage starts to show up depending on the day.
Sure.
I mean, if it's a hot day on
you got any breeze or not.
Yeah, breeze and all that. But whereas, to compare, you get into like 10, 12 shots with a steel can to get the same effect with Mirage.
Gotcha.
So generally, I mean, titanium suppressors I think are suited better for a hunting application. Lower round count, generally cold conditions when you're going and shooting. And then you obviously lighter weight on the end of the barrel. So it can be easier to pack around.
And there's some other, maybe not really worth mentioning, some other more exotic materials too. I mean, you hear guys talking about Inconel and some other things. What's your take there?
Man,
I know Inconel is very difficult to machine.
It's very difficult to machine. There are some guys that are 3D printing it now. The place I always get to is the stainless steel that we use on our suppressors. It's very commonly used in the industry.
Yeah.
And it's got about as good a material properties as you can get.
Yeah.
When you go to these exotic materials, you're getting minimal gains on strength and weight. Albeit your strength is higher, but you're trading that off for some of these very niche manufacturing processes.
Sure.
Hard to machine. You can 3D print it.
And as a result, way more expensive to produce and way more expensive to the end consumer.
Yeah.
Right.
And the thing I want to touch on with 3D printing too is, a lot of people just assume it's 3D printed and you just print it and take it off the printer and you're good to go. You still have to machine it.
Still got to machine it.
You still have to put threads in
right?
it. Yeah, exactly. And that creates some issues, right? Because you have a 3D printed surface. It's not as smooth and precise as a machine surface, right? So you got this thing, you got to figure out how to hold it in a machine so you can cut these threads. Those threads have to be very precise in relation to the bore. So if you get crooked on a really long suppressor, a baffle strike is very easy.
Yeah.
Very easy for that to happen. So
yeah, you're seeing a lot of guys moving, and in our research, moving towards these 3D printed suppressors. And, I think if you'd asked me a couple of years ago, I think most guys would have said, that's experimental realm, right?
Yeah.
But I think you're seeing production 3D printing coming into not just this space, but a lot of other spaces that it's very viable. And I think we're seeing a lot of people moving that direction for good reason. But it's not without its limitations, right? I mean, you can create really crazy, wild internal dimensions with a 3D printed suppressor that you could not do with traditional machining.
Yeah.
But it's not without limitations as well. And we've learned that, you still have limitations on how you can produce that, the orientation that you're doing it. You can't be 3D printing overhanging structures and things like that. So there are some still limitations in there. And so, depending on what you're trying to do, different directions call for different.
Yeah, exactly. I mean, maybe let's just talk about that real briefly. Like when you 3D print, you start with a tray, and it's, like a 2D printer. You're basically going to start printing layer after layer after layer.
Right?
And so you're really constrained with 3D printing into kind of what I call the Z direction, the vertical direction, or along the length of the suppressor. You can only print so much angle as it's going out, because it has to build from layer to layer. It has to build on the next layer. And generally, with a lot of 3D printers, like once you get past that 45-degree angle, you start getting some limitations.
You lose some resolution.
You got to get creative, and you lose resolution and things like that. So it does have its limitations, but I think there's a lot more design freedom with it, because you can achieve geometries that you can't CNC machine. So on the design side, it opens up a lot more doors on being able to route gas, through, from one baffle. You can route it along the length of the suppressor back into a baffle. So now all of a sudden you've got some of that gas blowing back the opposite direction, canceling some of that gas flow out.
Right.
So it opens up some of those doors where you can't really machine, tubes into a suppressor along the length of it. Whereas it's possible with 3D printing. So
yeah, for sure.
There's a lot there. And I think, metal 3D printing and just 3D printing in general changes every day.
Oh yeah.
And it's a very quickly that industry is moving.
Technology.
Yeah, exactly. So definitely something we're going to keep our eye on as we move forward, especially just on the design side. You can achieve things that you're not really constrained by traditional machining. And I think we can get some more effective designs just because we can engineer the gas flow the way we want it in the suppressor. So,
one other material we didn't mention is aluminum.
Yeah.
And, I think it's easy to think of aluminum as cheap as it's easy to come by, it's easy to machine, but it actually has some pretty good properties in certain applications as well.
It does. Yeah. When you start looking at the strength to weight ratio of aluminum, it's lighter, but not as strong as titanium. And that's kind of your limitation, is that overall strength, it doesn't yield itself to making a pure aluminum suppressor. You have to be able to put titanium or steel into some of those areas with a lot of pressure. But there's people out there doing it, and it's something we're looking at now, supplementing some of these components.
Use it strategically.
Use it where it's going to work the best for the design. Where failure is not going, the structural failure is not going to be a thing, where that pressure is going to be lower. And the thing that gains us is lower mass weight. Aluminum is lighter than titanium. It is probably one of the best materials and most widely used, like you said, for that reason, just because it has a very attractive strength to weight ratio and it's easy to machine.
Right.
So that's definitely something we'll look at, putting that in there. I would have to say one additional caveat is that thermal conductivity.
Yes.
It's
even worse with aluminum.
It's even more than the titanium is. So that's something that we'll keep our eye on here, right? But you can still counteract some of that heat with, by putting different things. Surface area is how that heat leaves the can. So the more surface area they have, the better, the faster it's going to cool off, if you will.
Sure.
So there's certainly things you can do on the design side to help mitigate that. Definitely something we're keeping our eye on with some new designs moving forward.
Cool. Well, I wanted to maybe just close with a quick discussion on what makes a good suppressor. And, not to tip our hand too much, but there's probably some things that we've learned here recently.
Yeah.
And, I think it's probably insightful for guys that are shopping for suppressors. I'll say this. I mentioned earlier, we built these suppressors, 4 or 5 years ago, maybe 5-6 years ago. And we're really happy with them then. 5 years, 6 years down the road, I think the nature here at Gunworks, we always are looking for the next best thing. So we're kind of bored of it, right? It's like, man, we need to make those things better. And that's old news. I think the one thing that we learned going into this most recent project is how good our old suppressors really are.
Yeah.
And, we went into it thinking, oh, we're gonna just freaking blow by these old suppressors and just next gen, it's gonna be amazing.
Yeah.
And we're working that direction, but what we're learning is it's a tall order to beat those original Gunworks suppressors. They are phenomenal.
I think physics kind of humbled us there
exactly
a little bit.
Right.
I do believe that's where kind of the suppressor industry is right now. Is we're knocking on the door of what physics says we can't
There's
do.
a law of diminishing returns there, right? And I think where we're at is, there it's not like there's just this bottomless limit on how quiet you can get a suppressor. Go watch a video. I can't remember who it was. One of the YouTubers made that video with, it was like 100-foot long suppressor. They screwed baffle after baffle after baffle after baffle together, literally 100+ feet long suppressor. And it was still not quieter than like a foot long suppressor or something like that.
Yeah, exactly.
So there's diminishing returns there. And basically at that very, top tier of suppressor performance, you're squeezing just minuscule bits of performance out of those. What makes a good can and a great can is pretty marginal differences, right?
Yeah, I think from good to great is just the optimization of that suppressor. When you really kind of break down that optimization, right? I talked about that expansion chamber, getting the right volume there to where you're big enough to take that, all that initial gas out of the equation, but not small enough to where you're creating a pressure spike that could have some unintended consequences there.
Yeah.
So you've got an optimum entrance chamber, and then you follow that up with the right number of baffles that are oriented in the right place. And then you have that kind of that exit of the gas. How is all that gas exiting the muzzle and how is it flowing out?
Yeah.
I think there's a lot to that optimization there. Like I said earlier, it's an iterative approach. I mean, there are fundamental design things that we can lean on and old designs that we can lean on. But like you said, that M baffle is a very effective design. And there's a reason the entire industry has at least a M baffle can that's in their lineup. Right. So, I mean, that's just the biggest thing is who's, providing the most sound suppression with the least amount of mass weight. I mean, that you break it down into simple terms, that's what it is.
Yeah.
And there are certainly designs that lend itself better to less mass weight, but they might be a little louder.
Yeah.
I mean, we designed a suppressor a few weeks ago that was really quiet, but it was a pound.
Yeah.
And it's like, there's a place for that, but not on the end of your
hunting rifle.
Yeah. Your mountain hunting rifle.
And I guess I would add a caveat there that even the mass weight thing is a goal for some, but not for others.
Exactly.
Right? Others might be looking, outside of really the Gunworks realm, but might be looking for a full automated can or something that's, that there's a million different applications, whether it's going on a gas gun or a bolt action rifle. We've really tried to focus our efforts. Our core business is hunting, and, long range hunting rifles and large magnums. And so that's what we've optimized for. And I think that's what we'll continue to at least put our focus on, maybe delve into some other things in the future. But so with that in mind, I think the sound suppression to mass weight is that ratio is the right kind of key performance indicator for us as far as the suppressor design is concerned.
Yep. Yeah. I mean, I'll circle back to like the laws of physics. It's like there's only so much you can do, and it's just who's doing it the best with the least amount of material is really what it comes down to.
Yeah, for sure.
And that's the mission we're on right now is to, basically have the best core and expansion chamber and exit chamber for a 6.57 and 300 caliber rifle. Right. And really with that, long range hunting consumer in mind. Yeah. That's the goal.
Now, here's the thing. I think that it's human nature, and it's really easy. We see this in rifle systems all the time. It's like, well, what kind of groups is that rifle what's your accuracy guarantee or whatever? And it's really easy to focus on what is that one thing and is it the best at it. But it really, I think as a consumer and as people designing products for consumers, and for ourselves, right? We need to look at it, a full package of features. And so it's really easy to say, well, is that the quietest? Is that rifle the most accurate? Is that car the fastest?
Mm-hmm.
You know, it's like you don't go buy a car that's, well, what's the fastest one on your lot? Okay, I'll take that one.
Mm-hmm.
Right?
Yeah.
At least not me and you looking for putting strapping a kid in the back seat and whatever else. And so, you know, I think the thing that I would urge people to consider is not just what is the quietest, but what is the best suppressor for me, because the quietest suppressor may not be the best one for you.
Yeah.
What is your mounting system? Is it going to maintain precision in your rifle? Is it going to reduce or be repeatable on and off? For me, honestly, as a long range guy, you know, sometimes you got to take that suppressor off and put it back on, you know, on your way to a hunt or whatever. And I would rather that suppressor go back on and maintain absolute perfect zero and give up a couple decibels in that, because I don't have to have movie star, you know, sound suppression. I just need it to be quiet enough to not blow my eardrums out when I take that one shot on the mountain.
Exactly.
Right. So, you know, weight, a lot of times, you know, we've got like our 6 suppressor is small. It's not the quietest can out there because it's very small, and it's largely a function of volume that's providing that that sound suppression efficiency. And so that's a really great can that's light, it's compact, but it's not the quietest thing out there. But I don't need that on a sheep hunt where I'm going to take one shot in a matter of 10 days.
That's exactly it.
Right.
Yeah. And when you look what we do here, right? I mean, that cold bore has to be on target, right? And it has to be spot on. More importantly, you got to be able to follow it up. Hopefully not, but
for sure.
I mean, you know, having that group size is definitely huge. And that's probably the most challenging part of product development is you have these metrics and it's full of a bunch of checks and balances, gives and takes, right? Where it's got to be quiet, but it also has to be precision. And that's kind of where product management steps in now is what's more important. Do you
pressure's on, right?
Do you want your cake or do you want to eat it, right?
And we want to have it and eat it too sometimes, but it's trade-offs, right? And we're learning that with current projects, several current projects. You've got to figure out what is the most important and where can we find that mix and that balance that's going to provide the perfect product for the application that's designed.
Yeah, because you have sound, you've got your precision. It also can't weigh a pound. It has to look cool, you know, and
durability and
manufacturability, durability,
cost,
it's like
all that.
Yeah, it's a holistic approach to product development that you kind of have to check all the boxes with any given product. Yeah, and suppressors are definitely a challenge in that space because, like I said, they're so iterative in nature. But I mean, that's the thing we'll be committed to is setting those metrics up and, you know, in a goal and threshold type of look like we've done and not releasing that product until we've met the bare minimum, you know, worst case, but best case, we're at the goals of everything. Right. So that's kind of what we'll be committed to on all of our products, suppressors included, moving forward.
Absolutely. Well, it's been kind of a fun discussion.
Yeah.
You know, I think we'll continue along this thread on several different product lines and, you know, what makes how to make a good XYZ, whatever else. Excited for those guys. If you're listening and you got questions, send them in. We'd love to, you know, if you want to hear more about this or learn about that, shoot those questions our way and we'll be sure to touch on those on future episodes.
Yep, definitely.
Cool. Till next time.
If you like what you're hearing here, please take a second and give us a 5-star rating and a positive review on iTunes or on your favorite podcast app. We appreciate your feedback and suggestions for topics you'd like discussed or questions you want answered on the podcast. You can reach out on Facebook or Instagram or send us an email to podcast@gunworks.com. Also, be sure and check out our full offering of long-range gear at gunworks.com. Use promo code LRP for free shipping on any order.